Imagine waking up after a full night in bed. You slept for 7 or 8 hours. Your alarm rings. You sit up, but something feels wrong. Your mind feels heavy. Thoughts move slowly. Simple tasks feel strangely difficult. You struggle to concentrate on conversations. Your memory seems unreliable. And throughout the day, your brain feels wrapped in a strange mental haze. Millions of people describe this experience with a simple phrase: brain fog. But what exactly is brain fog? Is it simply fatigue? A lack of sleep? Or could it be something deeper? A signal from the brain itself? Recent discoveries in neuroscience suggest that brain fog may be closely connected to one of the brain's most important maintenance systems, the system responsible for cleaning waste out of neural tissue while you sleep, the glymphatic system. And when that system fails to complete its nightly cleaning cycle, the consequences may appear almost immediately. To understand brain fog, we first need to understand how much work the brain performs every single day. Your brain is one of the most energy-intensive organs in the human body. Although it represents only about 2% of your body weight, it consumes nearly 20% of your total energy. Every thought you produce requires neurons to fire electrical signals. These signals trigger chemical reactions inside brain cells. And every chemical reaction produces metabolic waste. Throughout the day, the brain accumulates a variety of byproducts. These include molecules such as adenosine, lactate, carbon dioxide, protein fragments, inflammatory signaling molecules. Most of these substances are harmless in small amounts, but if they accumulate, they begin to interfere with neural communication. Neurons become less efficient. Signals travel more slowly. Cognitive clarity fades. This is why the brain must remove these substances regularly. And the primary time when this removal happens is during deep sleep. As we explored in previous videos, the brain activates its glymphatic cleaning system during slow-wave sleep. When deep sleep begins, brain cells slightly shrink. The spaces between neurons expand, and cerebrospinal fluid begins to flow through microscopic channels inside brain tissue. This fluid acts like a cleansing solution. It mixes with the interstitial fluid surrounding neurons and carries away metabolic waste. Throughout the night, wave after wave of fluid pulses through the brain, rinsing, flushing, restoring the brain's chemical balance. But this cleaning process depends on one critical factor. Deep sleep must occur. If deep sleep is shortened or interrupted, the glymphatic system cannot complete its cleaning cycle. And when that happens, metabolic waste remains inside the brain. One of the most important molecules involved in brain fog is adenosine. Adenosine is a natural chemical that accumulates in the brain during wakefulness. Every time neurons burn energy, adenosine levels increase. As the day progresses, this buildup creates a growing sensation of sleep pressure. It is the reason you begin to feel tired in the evening. During deep sleep, the brain gradually clears adenosine from neural tissue. When this process completes, you wake up feeling refreshed. But if deep sleep is disrupted, adenosine levels remain elevated. This can produce the sluggish mental feeling commonly associated with brain fog. Your brain is still carrying chemical signals that say you should still be asleep. Another molecule that contributes to brain fog is lactate. Lactate is produced during intense neural activity. Throughout the day, neurons metabolize glucose for energy. One of the byproducts of this process is lactate. In moderate amounts, lactate is harmless. But when lactate accumulates, it alters the chemical environment surrounding neurons. This can interfere with neurotransmission and reduce the efficiency of neural networks. During deep sleep, glymphatic flow helps clear lactate from brain tissue. But if sleep quality is poor, lactate levels remain elevated. This can contribute to feelings of mental fatigue and cognitive slowing. Brain fog is also influenced by the buildup of inflammatory signaling molecules. When the brain is stressed, whether by poor sleep, illness, or psychological stress, immune cells within the brain can release inflammatory compounds. These compounds alter how neurons communicate with each other. They can reduce synaptic efficiency. They can slow information processing, and they can create the sensation that the brain is operating under reduced capacity. Sleep normally helps regulate these inflammatory signals, but when sleep is disrupted, inflammation can persist, and this can amplify the symptoms of brain fog. Interestingly, many of the same molecules involved in short-term brain fog are also involved in long-term neurological health. For example, insufficient glymphatic cleaning can contribute to the accumulation of beta amyloid, the protein fragment associated with Alzheimer's disease, while brain fog does not mean someone is developing Alzheimer's. It highlights how sensitive the brain is to changes in its internal chemical environment. When waste removal slows down, cognitive performance changes. The brain sends subtle signals that something in its maintenance system needs attention. Brain fog can also appear after intense mental effort. Have you ever experienced the feeling that your brain simply cannot process information anymore after hours of focused work? This sensation may reflect the temporary buildup of metabolic byproducts in neural tissue. The brain has been operating at high metabolic intensity, and until the next sleep cycle removes those byproducts, cognitive performance begins to decline. This is why sleep is so essential for learning. During the night, the brain not only consolidates memories, it also cleans the metabolic residue left behind by intense thinking. Modern lifestyles often interfere with this process. Artificial light exposure at night suppresses melatonin. Late-night screen use stimulates neural activity when the brain should be winding down. Caffeine blocks adenosine receptors, masking sleep pressure. Chronic stress increases cortisol levels, which can fragment sleep cycles. And irregular sleep schedules disrupt the circadian rhythm that regulates deep sleep. Each of these factors reduces the amount of slow-wave sleep a person experiences. And because slow-wave sleep drives the glymphatic cleaning system, these lifestyle factors can indirectly contribute to brain fog. Interestingly, even dehydration can influence cognitive clarity. Cerebrospinal fluid, the liquid responsible for brain cleaning, is composed largely of water. When the body is dehydrated, fluid balance in the brain may be affected. Although the brain carefully regulates its internal environment, prolonged dehydration can influence circulation and neural performance. Staying adequately hydrated supports the broader physiological systems that maintain brain function. Physical activity also plays an important role in brain health. Exercise improves blood circulation and supports vascular health. Because glymphatic flow is partly driven by the pulsation of blood vessels, healthy circulation may enhance the movement of cerebrospinal fluid. Research has shown that individuals who engage in regular physical activity often experience deeper sleep, and deeper sleep strengthens the brain's cleaning cycle. In this way, exercise indirectly supports cognitive clarity. Another interesting factor influencing brain fog is sleep timing. The brain operates according to a circadian rhythm, a biological clock that regulates sleep and wakefulness. When sleep occurs at consistent times, the brain can enter deep sleep more efficiently. But irregular sleep schedules can disrupt this rhythm. Shift work, jet lag, and inconsistent bedtimes can reduce the amount of slow-wave sleep a person experiences. Even if total sleep time appears adequate, the quality of sleep may be reduced. And when slow-wave sleep declines, the brain's cleaning system becomes less effective. Brain fog, therefore, should not simply be dismissed as normal tiredness. It may represent a signal that the brain's internal maintenance systems are under strain. A reminder that the brain requires regular cleaning just as much as it requires energy. When sleep is deep and uninterrupted, the brain resets itself. Waste is removed. Chemical balance is restored. Neural networks regain their efficiency, and the mind feels clear again. But when sleep becomes fragmented or insufficient, the brain begins the next day carrying the metabolic residue of the previous one. Waste remains in neural tissue. Neurotransmitter balance shifts. Inflammatory signals linger. And the result is a mental haze we call brain fog. The brain is constantly communicating with us, sometimes through emotions, sometimes through fatigue, and sometimes through subtle cognitive signals. Brain fog may be one of those signals. A reminder that the brain's cleaning system needs the one thing it cannot function without: deep sleep. In the next video, we will explore how modern lifestyle habits may be silently interfering with the brain's nightly cleaning system. From artificial light to caffeine to chronic stress, we will examine how everyday behaviors may disrupt glymphatic flow. And most importantly, how simple changes can help restore the brain's natural detox cycle. Because protecting the brain's cleaning system may be one of the most powerful strategies for protecting long-term cognitive health.